Hello everyone, let's look at Leetcode question 346, moving average from data stream. Given a stream of integers and a window size, calculate the moving average of all integers in the sliding window. Implement the moving average class. Moving average in size to initialize the object with the size of the window size. Double next int value returns the moving average of the last size values of the stream. Okay, the constraints are that the size is between 1 and 1,000, the values are between negative and positive 10,000, and at most 10 to the 4 calls will be made to next. Okay, let's look at the examples, make sense of all this. Okay, so what's happening here is that we define the size of the initial window. Okay, this window will contain a limit to the number of values of the stream that will be processed. So what we do is define private q to be a new array dq. So this is our q, the size and sum are in int and double values, and we have the constructor here and the next method, which will process the average, the moving average that we want to figure out, and it has an if condition that checks if the q size or the moving average initial window size is not greater than 3 or is 3. If it is, well, it's 3 in this example, but the size changes determined on the initial definition of the moving average, and we need to not have it be greater than 3 or equal to 3 in this case. Okay, so let's run through this example. So we initialize with the moving average to be a new object 3. Okay, so that just means that we're defining the size to be 3. Public moving average size constructor, this dot size equals size. Moving average is new moving average 3, so size is equal to 3. Okay, so we don't return anything since there is no next value in the window. The data stream values are not being processed yet, so we return null. And then moving average.next is 1. So we finally have a value to be processed, and it's 1. So double next int value is 1. If q size is equal to size, that's not the case. There's nothing in q. So we simply do sum plus equals value. So the value was dot next 1. So sum becomes 1.0. Sum plus equals 1.0. And then q dot offer val. That just means we add the value to the q. So the q has 1. And then we return sum divided by q size. Sum is 1. Q size is 1. 1 divided by 1 is 1. We return 1 for this first dot next. Okay, so then we have another call. Moving average dot next equals, or is 10, dot next 10. So we process it in the next function and we check, is q size equal to size? 1 is not equal to 3. We don't worry about popping anything out of the queue, so we simply add the sum value. So 1 plus 10 is 11.0. Okay, so we add that value to the queue now. It was the 10. Okay, and then finally we return sum divided by q dot size. Sum is 11. 11 divided by 2 is 5.5. So the moving average is 5.5. We return it and move to the next object call, moving average dot next 3. Okay, so the next value is 3, and still the q size is not equal to size. 2 is not equal to 3. Sum equals plus equals value. So 11 plus 3 is 14. 14.0. We add this value to the queue. It goes to the back. Remember, last in, first out. And then we return sum divided by q dot size. What's the sum? 14.0 divided by q size. That's 3. Okay, so 14 divided by 3 is around 4.6667. We return 4.6. And then we move to the next call, and that's moving average dot next is 5. Okay, so if queue size is equal to size, finally the queue size is actually 3, so 3 is equal to 3. This means sum minus equals queue dot pull, so we remove this 1 and remove it from the total sum. 13.0 is what becomes the sum. The Q is now just 10.3. Q is now just 10.3. And why are we doing this? Because the moving average size is window size 3. Okay, we can't have a data stream with values that are too big for the window size, so we have to remove the first value from the start of the queue, and that allows us to add then the next value to the queue. So let's do just that. So sum plus equals value. Sum was 13 now, and we add 5. That was the 5, so moving average dot next is 5. The double sum is 18.0. Okay, so sum is equal to 18.0. We add then q dot offer 5. The q is now 5. Notice that the queue size is 3 again, but we don't need to worry about it being 3 after the fact that we popped off the first value of the queue, because it's 3 is the limit of the size of the window, and the next iteration, if there was a next, would then qualify us for popping off a value. Okay, so we can have it as 3 but not over 3. So we added the 5 and we returned sum divided by q dot size. Okay, sum was 18.0 divided by q size 3. 18 divided by 3 is what? What is 18 divided by 3? Alright, so we simply return 6.0, and that's the last call here for this moving average dot next. And you see then that this is a sequence of object calls, and we've done just that with the limitation of the moving average. Okay, so let's check the solution, and it works great. So what is the time complexity? Well, everything is static besides the method double next, so the time complexity of next is O of 1, because all operations, addition, subtraction, division, are constant time operations. The space complexity of the moving average class is O of n, when n is the size of the moving average. This is because the class uses a queue to store the elements, and the size of the queue will be equal to the size of the moving average. Okay, so the space is O of n. That's it for this video. Thank you so much for watching. See you next time.